Next we are discussing inequalities in integration. So here we are going to discuss inequalities in integration. In this one, first point we are discussing, okay, inequality for a monotonically increasing function. Okay, for a monotonic increasing function, okay, for a monotonic increasing function in the interval closed interval a to b. So if a function is there that is monotonically increasing function in the interval a to b, okay, so what we are doing, this is a function monotonically increasing, lower limit is what, x equal to a, and upper limit is what, x equal to b. So for that, this function name we can give what, y equal to fx. Okay, now integration a to b fx dx. So what it tells, integration a to b fx dx, what it tells, this area, okay, so integration a to b fx dx will come about this area. Okay, now here we want to find out inequalities. So this area we can say, if this value is what, the x equal to a, so this value is what, y equal to f of a, and this is what, x equal to b, this value is what, y equal to f of b. Now if I join this one, so you can see this area. What is this area? So this area we can say that this width is what, b minus a. So area will be what, b minus a into f of a. So we can say that this area is greater than this one. So here we can say that this is greater than f of a into b minus a. Now here if I take this area, so here this area if I take in blue, so what is the area here? This area will come what, full area b minus a, width into height f of b, because it is a rectangle. So this area is what, b minus a f of b. So here from the diagram we can say that this area will be greater than this one. So we can say that this should be what, less than b minus a into f of b. So in this inequality what we can say, if we have monotonically increasing function, okay, for example y equal to fx in the interval a to b, so integration a to b fx dx will be greater than difference between limits, upper limit minus lower limit, into function value at lower values of limit, that means at a. So what will come, f of a, and it is what, less than difference between limit and function value at upper values of limit, that is b. Okay, at b upper values of b, what will come, value f of b. So this is what, b minus a into f of b. So this is your first point. Next we are discussing second point. What is second point? For a monotonic decreasing function in the interval a to b. So here we are taking monotonically decreasing function. So this function we are taking, so lower value is what, x equal to a, and upper value is what, x equal to b, and this one we are taking y equal to gx. So y equal to gx is what, monotonically decreasing function. So here you can see what is this value, y equal to g of x value put here, so x value is what, b, so g of b, and at x equal to a, this value what will come, y equal to g of a. Now this one area, so how to get this one area, integration a to b gx into dx. So this will tell what, this one area. So here we have to use inequality in the interval a to b. So here you can see, if I take this rectangle, so what is the area of this one? So area of this one what will come, see this is a rectangle, so here width is what, b minus a, this is what, width, and what is height, this one. So what is the area will come, b minus a into g of b. So from the diagram we can see that this value will be greater than this one. So we can see that this one is greater than b minus a into g of b. And if you check here, if you take upper value, so this rectangle if I take, okay, then here you can see in this rectangle what will come, what is the area will come, this one, full area is what, b minus a into g of a. So from the diagram we can say that this area will be what, greater than this one. So this will come what, less than b minus a into g of e. So from here what we can say, if a function is monotonically decreasing, then integration a to b gx dx will be what, greater than difference between limit into value of function at upper values of limit, that is b. So at b, what is the function value, y equal to gx, value at x equal to b, what will come, g of b. So here what will come, g of b, and this integration value will be what, less than difference between limit and function value at lower values of limit. At x equal to a, what is the y equal to gx value, so that will come g of a. So this will come g of a. So this is what, second point. Next we will discuss third point. For a non-monotonic function, for a non-monotonic function, okay, so if I take for a non-monotonic function, so here this is what a, this is b, and this one is c. Here we are getting what, minimum value of function, okay, and this one we are taking function is what, y equal to h of x. Now here you can see this one area. How to get this one area? Integration a to b h of x into dx. This one area we can give what, integration a to b h of x dx. Okay, now here what is the lower value of function, that is this. So this value what will come, if I put c here, so this value will become y equal to h of c. Now if I take this rectangle, below rectangle, so what is the area will come of this rectangle, b minus a into h of c, this will come. So you can see from the diagram, this value is what, less than this one. So this will what, less than b minus a into h of c will come. Now see here, a value is what, f of a, and this one value is what, f of b. So here we, from the diagram we can see that f of a is what, less than f of b. Okay, now here what we can take, here we are taking upper value, because here f of a is less than f of b, so we are taking f of b highest. So if you check this one area, okay, so this one area I am doing like that. So what is the area of this one? So this one area is what, b minus a into, so this one value will come h of b, and this one value is what, h of a. So this is also h of a is what, less than h of b. Okay, so here we can say that b minus a into highest value is what, h of b, so this is what, h of b. So from the diagram we can say that this value is greater than this one, so this will what, less than b minus a into h of b, this will come. So for a non-monotonic function, okay, for example y equal to hx, so here integration a to b hx dx will be what, this value is greater than difference between limits and lower values of y equal to hx function. So lower value we are getting at x equal to c, and what value will come, h of c. So here we are multiplying h of c, and this one is less than difference between limit and highest values of h of x function. So highest value we are getting at x equal to b, so that is h of b. So here we are multiplying h of b. So this is third property.